Alright, hi, I'm James. I work upstairs at Cultram, and I'm going to be talking about achieving and maintaining 60 frames per second in your web app's animation. So, I guess I'll start by saying CSS or JS animations. That's kind of probably a controversial thing to bring up at Melb CSS. But kind of like my answer to this is doesn't really matter that much. There's a lot of things you can read that were written at various different times that apply various different amounts today about performance that you can achieve with CSS and JS animations and transitions. But these days, the main thing that really matters is what properties you're actually changing when you're animating. So the main ones you can really change quite a lot or quite frequently in today's browsers are translating things, moving around, scaling, rotating, and also in some cases opacity. The reason for this is because these things can be done basically on the GPU. And so I'm just going to show an example of a library that makes use of translations. This library is using JS to do animation. It's a library that's put out by Facebook. It was adapted from work they did on something called Pop, which is a library that they wrote for their like native apps. So like their iOS, I think Pop was written for iOS, and then there was another one called Rebound for Android, and they basically use Spring-based animation. Actually it's like a Spring-based physics system, and so they can create some kind of like dynamic living systems that that have some properties that you can't get with just normal easing-based animation. So, but the really cool thing about this is they're able to achieve like really good frame rate despite the fact that this animation is being done in JS. So, if I show in the DevTools, what's going on? Hopefully, come on. Yeah, so if you're not familiar with, if you're not familiar with this view in the Chrome DevTools, this shows a frame rate graph, and so you really want it to be like up here because that's 60 frames per second, frames with these like red things are basically where the frame took longer than 16 milliseconds. Which, if you want to hit 16 frames per second, that's all the time you've really got to get a frame of animation done. So this is like what we want to achieve. And so, I use this as an example, not really because of I just think it's a pretty cool example, but they've done this particular example using only those 4 properties that I mentioned earlier. And sometimes we do need to animate some other stuff. That's okay. Like you can use things other than these 4 properties, but these are the ones that you can rely on to be pretty fast. So I'm just going to show something in our app that we build at Cultram, which is a place where we've used animations which are animating other properties, and so like So here we're animating width and height. There's width being animated here, and height being animated on this thing. And you can see that we're still able to achieve pretty good frame rate, but so there is still some like room for improvement. There's a few long frames. These ones are not really ones worth worrying about. These ones where you've just triggered off an event, because they're usually going to be triggering off. When an event's triggered off, a lot of stuff probably happens, and there's a good chance that you'll drop a frame there. But the important thing is that like you do get these kind of nice around like 16 millisecond frames for the rest of the animation. So at Coltramp, we've sort of like noticed over time that as people like iterate on features that you developed, and you know, requirements change, and people come and like add things, and you know, little bits of CSS get added here and there, or like things get sort of like tweaked but not really re-implemented from scratch. You can find that animation performance can start to suffer, and so this is something I've been thinking about a lot. And although you can go into the dev tools and like see, we've got some little red flags here, that's not really something that you can do like all the time. You know, like if you're waiting for someone to notice an animation performance problem and then go and diagnose it and all that, there's a good chance that they're just going to keep creeping back in. So recently I was watching a talk, I think it was at Web Directions, but I can't really remember. But basically someone was talking about using the Adobe's Topcoat library, which is like a CSS kind of widgets library for their Adobe Air platform. And they basically implemented kind of like a build with like a bunch of regression tests based on animation performance. And so they were using Chrome telemetry, the Chrome telemetry APIs, to basically collect a whole lot of measurements, things like frame rate and like CPU usage and all that kind of stuff, when putting like a whole bunch of UI components on the page, like a whole bunch of copies of the same component. And so when those kind of telemetry measurements shot up, they knew that there was a performance regression. So I kind of like went down the rabbit hole of looking into the Chrome telemetry APIs, and I came across a bunch of stuff written by this guy, Parashuram, who works at Microsoft, and he's basically obviously really interested in this topic, as I am. And so he wrote this module called BrowserPerf for a node module. It's on NPM. And basically it's a thing that uses Selenium to run various browsers and use the various browsers like different things that they expose. Like in Chrome, there's the telemetry APIs. In Firefox, I think it uses possibly the debugger API. But anyway, there's a whole bunch of different APIs that each browser exposes for collecting all these kind of metrics. So with this, we're able to do a sort of like something like an acceptance test, but recording all of these kind of performance data. So I'm just going to run something we've built in one of our like hack days at Coltramp, or dev days. Hopefully I've like set everything up right. And so it's just running a couple different browsers using Selenium, and just going through and clicking on some stuff and just doing some interactions that show some animation happening. And while it's doing this, it's recording a bunch of, it's recording all those stats. And when it's done, it'll vomit them all out. And just while it's running, I'll show you what one of these tests looks like. So we're able to using some cool ES7 stuff, we can have like a fairly nice, simple looking test kind of looks like cucumber or like a capybara kind of thing, but basically it's just going to somewhere on the page, scrolling down, clicking on something which animates, and then waiting for a while so the animation finishes. But then at the end here we've got these, we've got an assertion that's basically saying during this test, or after this test, the mean frame time can't be over 25. 25 is like a bit loose. Like we really wanted like 16, but you know, stuff maybe like varies a little bit in a testing environment. So the important thing is, oh man, did it get stuck? I don't know. Maybe it needed me to like watch it to do anything. Yeah, so this is just running through a few pages on the app that we developed at CultureAmp, and so we can see that this is dumped out. I've just put in an environment variable to dump out all of the different stuff that browserperf collects. So it's like a huge amount of different stats about the session that we just ran through. And there's a whole lot of stuff that's like browser specific, but you can pull out a few things that are shared or like available across all the different browsers. So one of them is it's not alphabetically sorted, so that's not very helpful, but there's this mean frame time RAF. So that's basically how long each request animation frame took, and there's like another one somewhere that's dropped frame count. So that might also be one you want to like assert on if you want to make sure that your animations are performing as well as they were the day that you created them. And so this little bit of like assertions that we put on top of what browserperf does, which is just the collecting of the data. We've basically been able to say that yeah, this passed in Chrome and Firefox. And so the reason why that's really useful, like as I kind of alluded to before when I was talking about over time, people come along, add little bits of CSS here and there, and performance can go downhill, is that you don't usually notice performance regressions when they happen. Often it's like a kind of death by 1,000 cuts kind of scenario, or sometimes it's just, it already felt like not that great because of the previous incremental performance regression, so you're not going to notice it feeling just a bit more not that great. But if we have some like build step or like continuous integration test like this, we can actually like fail a build when it pushes us over some performance threshold. And another thing that can be really handy about this is that often like performance issues can be quite hard to actually track down. Like I showed the Chrome dev tools before, but to be honest, a lot of the time I actually can't really figure out what I need to find out in here. Like some of the stuff, yeah, you can kind of understand. Like if it's spending all of a frame doing something, then you can tell that's something to look into. But then sometimes there's like frames that don't seem to be actually doing that much, or like the kind of information that the browser gives you is not that clear. So armed with an automatic way of checking performance, you can do things like, if you have it running constantly, yeah, it will like fail the build that pushes you over the line. But even if you haven't set something like that up, you can use tools like git bisect, which basically lets you go back through all of the history of a branch, for example, and run a test that either like passes or fails, and you can hone in on the commit that introduced the failing kind of condition. And so because this is a program that can run automatically, you don't need to manually go and look in the Chrome console or the Firefox console, because Firefox has this tool as well, although I didn't really notice that until recently. But because if you have like an automated tool that can do this, you can actually just set up git bisect to like run and automatically check out a commit, run the test. If it passes, go one way. If it fails, go the other, and like hone right in on the commit that broke performance. So that's why it's like a really good idea to have something like this. This page kind of shows a particular performance regression that we managed to introduce without really realizing to do with the way that these circles have been blended together. Knowing what the problem that caused this was, it seems kind of obvious. You know, using like blending is actually quite an expensive operation. We're using one of the mixed blend mode CSS properties. But at the time, it wasn't really that obvious. Now, you see, I've opened this up in Firefox, and this particular version of Firefox, mixed blend mode, really wasn't very optimized. So we can see that there's like something wrong there. But using a tool like the one we've got using BrowserPerf, we can hone right in on the exact commit that introduced that, and then we can look at it and be like, oh yeah, of course, it was because we're using blending modes. So yeah. So I think there's something else I was supposed to talk about, but I don't have a slide for it, so I guess I don't have anything else to say except we're hiring. And any questions?